Hello everyone, I'm Amir Hossein. Welcome to another training video. In this video I will introduce the new version of RTTOVpy which can support RTTOV version 14. You can get access to the application by cloning the application repository from GitHub. After cloning, go to the ERA5 input data. In this video I will show you how to run the RTTOV model using RTTOVpy application and using ERA5 input data. I open the name list. This application is about simulating a MODIS image. So for simulating the MODIS image, first of all you need to find the suitable coefficient, RTTOV coefficient, for the satellite that you want to simulate its image. This is the suitable coefficient for MODIS sensor, and this is the time of the simulation. I don't want to change the time of simulation, I just leave it. And area of simulation. Of course you can change these variables. Let's say domain name, you can change it to whatever name you like, and the domain geographical border, you can change it. Also time of simulation, but I just leave them. And let's focus on this block, satellite information. The satellite name index, for using the satellite name index, it should correspond with the MODIS, with the TERRA satellite. The TERRA satellite, let me show you the index for TERRA. Number 2, EOS TERRA is the satellite that we want to simulate, so here I put number 2. That is the EOS TERRA. And the channels is 18 and 27. How did I know that I want to how did I know these numbers? Let me show you how did I know these numbers. If you want to know the number of wavelength and the specification of wavelength supported by a coefficient file, you can use RTTOVpy application in this way. Actually, in the new version of RTTOVpy for RTTOV version 14, you have a new capability, the flag wavelength. So if I run it in this way, wavelength, and add the argument, the path to the coefficient file, and run it, wavelength, and run it, I can print out the list of all wavelengths supported by that coefficient file. So you can see that we have 36 wavelengths with their we have 36 channels with their wavelengths. So here in the name list I have set the satellite channel list to 18 and 27. 18 here is wavelength 0.9, and 27 is 6.7 micrometer. So these are two bands that we want to simulate using RTTOV version 14. And here are the name of the bands, the band 18 and band 27. You should try to set the exact name that you find in the satellite observation data. But here, since we will just we just want to simulate the satellite and there is no verification, you can put whatever name you like here. But these names should correspond to the number of satellite channel lists. We have 2 bands here, so here we need to have 2 names. And satellite position, satellite user defined position, I have enabled it. So here the simulation, here RTTOV suppose that satellite is positioned in the latitude of 47.5 and longitude of 3.5. And okay, here is a new block, historical TLE. If you want to run RTTOV with the higher accuracy or higher TLE information, you can enable this block, historical TLE. This is optional actually, but if you enable it, it looks for the exact TLE information. Actually, for if you disable it, RTTOVpy application still looks for TLE information, but the TLE information might not be much exact. It depends on your application. In this case, that you want to enable historical TLE, you need to register in this website, spacetrack.org. So let me show you spacetrack.org. Here, the website of spacetrack.org, you need to register it and get your credentials and put your credentials here. And after that, you can retrieve TLE information of the satellite and have a higher accuracy TLE information. Okay, post-processing, I just disable it because I have not yet run the RTTOVpy to because the first run is for making profile data. I run it, Python RTTOV. Let me run again, Python RTTOVpy. Since I have already downloaded the ERA5 data, it just used the downloaded data, so I didn't download it again. I used the already downloaded ERA5 data. And here we have generated MODIS profile. These are actually profile data that can be used by this shell script. This shell script is another generated file. So I can run RTTOV model using this shell script. This shell script use these profile data. These profile data, each of these profile data are the profile information over each grid points of the ERA5 information. So I run this shell script with the argument G4tran. G4tran was the compiler that we used to compile RTTOV model. I run it, and you can see that for each grid point in the ERA5 model, it is running RTTOV and generating outputs. I just stop it, MODIS output, since I have already run this step, I just copy the complete outputs here. MODIS output, and you can see that the RTTOV outputs are available here. Just let me show you one of them. Output, you can see that for the first grid point, these are our RTTOV outputs: calculated brightness, temperature, satellite reflectance, radiance, overcast radiance, transmittance, and so on. So this is for the first grid point in the ERA5 data. It runs it for all the grid points. Okay, now that the RTTOV model is run and we have RTTOV outputs, we want to make a netcdf file and make some plots of these outputs. So I open the name list again. I enable post-processing block to image plot all bands, enable it. I just skip, for this case I skip plot brightness, RGB brightness, temperature plotting. I just skip it, but I post process it. I convert the RTTOV output to netcdf and then plot the netcdf file. Run it, and here we have a new directory, MODIS. I open one of them, radiance. Here you can see the radiance. This output, this is actually RTTOV outputs that we have converted it to a netcdf data. So all the outputs are ready here on a netcdf data. This is for band 27 and this is for band 18. Also, these netcdf files, there are plots, visualized plots for each of these netcdf files. Of course, you can use this netcdf file for further analysis if you need. So this was the ERA5 application of RTTOVpy software. In the next videos I will talk about how to use RTTOVpy application for the WRF model output.